Hey guys! Today we're actually doing something a little bit different, because I've decided to finally take the plunge and learn how to write shaders, and I thought I could make a little series out of it for you guys. So, since I'm very German, as German as they come, I like to do things in a very structured manner, so I thought we could split it up topic by topic. Today we're going to talk about meshes. Then in the next episode we're probably going to talk about vector math or the types of shaders and so on. Well, I hope you guys stick around with me and you enjoy it, and let's jump in. So, meshes can be made up of n-gons, quads, and triangles. N-gons having 5 or more points, quads 4, and triangles, you've guessed it, 3. I'm not going to include n-gons and quads here, because rendering typically converts everything into triangles anyways, so for the aspect of shading and working in Unity, you won't need to know much about them. For the sake of easiness, we are going to look at the standard cube for our explanations. I've mentioned earlier that triangles are made up of 3 points. These points are called vertices. Vertices are represented in the mesh class as vector 3, so we can identify them by their coordinate in 3D space. Now, if you look at the screen right now, it might seem as if there are only 8 vertices within our cube mesh. But that is not actually the case. It has 24 vertices. This is because of the normals. Every vertex has a normal, which is a vector extending from the point of origin at 90 degrees to the surface. As you see here, there are 3 vertices in each corner of the cube, which brings us to a total of 24 vertices. Normals are very important as they are used to calculate how the light will hit the surface. Now, smooth shading means that the vertices that are positioned at the same spot are shared, and their one normal vector is going to be an average of each of the individual normal vectors, while in flat shading each vertex is its own and has its own normal, which makes much more sense for a cube, as you can see here. Vertices and normals are saved in the mesh class as arrays of vector 3. The mesh class also holds UVs, tangents, triangles, and colors, but let's discuss those one by one. UVs are very critical for writing shaders, as they allow us to map a texture to our vertices. Here we have a triangle. Let's assume the UV coordinates at the vertex positions are 0, 0, 0, 1, and 0.51. UV values fall between 0 and 1, which means they represent a percentage. So that means that the bottom left corner of our triangle should show the bottom left corner of our texture, and so on. This probably makes more sense when you see the texture applied to the triangle. And this is what our cube would look like with the texture wrapped around it. It is also important to remember that UVs belong to each vertex and are always ordered in anti-clockwise order. A mesh can also have multiple sets of UVs, which usually happens when more than one texture is going to be applied to the mesh. Tangents are used for shaders with bump maps, which are these weird looking blue textures that allow our surface to look bumpy. They are unit length vectors that follow the mesh surface in horizontal direction of the texture. They are defined by a vector 4 with x, y, and z for the directional vector, and w used to flip the binormal if it is needed. The binormal being a value between 0 and 1 that is calculated from the tangent and the normal and is used to modify the color according to the surface. The triangle array consists of lists of 3s where each of them is the index of the vertex it represents from the vertices array. Triangles can be used to define submeshes, which allow us to use multiple materials for different areas of our mesh. Like here, the eyes of our pig and its skin. If I drag a different material onto it, only the triangles of the submesh I'm hovering above will change. Let's talk about vertex colors. Vertex colors can be stored with an array of color or an array of color 32, which is a bit more efficient. This allows us to do cool effects by changing the color of our mesh per vertex, as you can see here. Generally speaking, this is producing a little bit less overhead than using textures, but also limits what you can achieve graphically a little bit. And that is it for today's video. I know it was a rather simple topic, but we are just easing into the whole shader situation. If you liked this video, please let me know in the comments or on Twitter. As always,